Okay, in this problem, we've got a shaft that's got a few different torques on it. I want to find the total angle of twist at NB. So in order to do that, I'm going to use the equation for the angle of twist between A and B. Basically, I'm going to break it up into sections and sum all of the twists of each section, which will be TL over JG for each section. So the first thing I need to do is find the torque in each section, which means I'm going to make 3 cuts. Like so, find the twists in each one and add them together. Okay, so we'll start it at the free end because then I don't have to find what the reaction at point A is. So I start with this guy, make that first cut. I've got 80 going this way, which means I have to balance that off by having 80 go in the other direction. Okay, now this is actually a negative because by right-hand rule, when I make that twist at that end, my thumb points into it. So we're going to try to follow the sign convention here to make sure. Now you can be a little, as long as you're aware and observant about what direction things are going in. I'm not super concerned as long as you stay consistent. But for this problem, we'll follow the sign convention. In a later problem, we might just be drawing lots more pictures to talk about what direction things are going in. Okay, we'll call that one negative. Okay, so when our next cut be a little bit longer like this. So I've got 80 right here. Then it comes back at 20, which means I've got negative 60. Again, right-hand rule. Got the rotation around that, my thumb points in, so that's going to be negative as well. Okay, make my final cut. So I have 80 going in this direction, got 20 going in the opposite direction, then I've got 30 going in this direction. So again, to balance that out, I need 90 heading back in this direction, which again is also negative because with the right-hand rule, my thumb points into it. So now I've got the torque going through each of the sections of the shaft. So now basically I'm going to find, I'll start by going from A to D, that first guy right in there, which is going to be negative 90, which is what I have for my torque, times the length. This section is 0.2, 200 millimeters. J is the polar moment of inertia. That's pi over 2 times the radius squared, where the radius is going to be 10 millimeters because the diameter is 20 millimeters. Not squared, I'm sorry, to the fourth. Okay, and then the G, the modulus of rigidity for steel, is 75 gigapascals. So it'll be 75 times 10 to the 9th. Now the answer that this gives me is in radians. Okay, and I get 0.0153, and again, that's going to be in radians. Okay, so we're going to do this now. We're going to move down now from D to C and calculate what's going on there. Now the denominator is going to look exactly the same as it did before, which will be JG, because the cross-sectional area and the material does not change in this section. So the only thing that's going to change in any one of these are the torque, which for this guy now is going to be negative 60. And the distance of this guy is 600 millimeters, or 0.6. Now remember that my answer is given in radians. That's going to be negative 0.0306. So the first section goes 0.015. Then from D to C is 0.3. So the total is 0.045 approximately. Okay. Now I go to the last section, which is CB. Again, the denominator looks exactly the same, JG, which is pi over 2 times the radius to the fourth. And then the modulus of rigidity is 75 gigapascals. And then this guy is negative 80. And it is 0.8 meters, or 800 millimeters long. That means the angle of twist on this guy is negative 0.0543. So now I'm going to add all of those together, and I get the total twist from A all the way to B is going to be negative 0.1002, and again that's radians, and that just comes from adding all of those together. Now, radians are not our preferred method. It's a little bit more descriptive, at least for me, to do it in degrees. So switching that to degrees, I get negative 5.74 degrees. So again, you just break it up into sections, find the torque in each section from that, find the twists in each section, and then add them together.